Yeah, thanks for inviting me. It's a pleasure to me, and I think for Obi also, and for the beaver especially. So, yeah, I'm Janosch. I'm at Obi since 2019. I'm the CG expert at Obi, leading the journey to a sustainable 3D pipeline. And what does sustainable mean for Obi? Yeah, kind of, if you spend the money to digitize products once, you want to own it and do with it whatever you want, independently from external production teams or from any other aspects. So that was kind of the sustainable thing. And of course, I'm going deeper in the next slides. So I'm going to explain you a bit about the situation I had in 2019. And then we go to the vision and approach we took at Obi together with all partners. And then we are moving to the first use case we had with our pipeline, like the 3D planning tool. And hopefully we have some time to do some Q&A after that. Okay, what is Obi? So you know Obi, I just learned. Thanks for Max for checking this, but I tell you something about it. Yeah, a key player in DIY in Europe since over 50 years, and we have over 43,000 employees. So 10 in 10 countries are the stores, so the central is in Germany, and we have millions of users on our Hey Obi app. We have hundreds of millions of users or visitors on our domains, and we have billions of revenue. But the most interesting thing for me is we have over 200,000 different products in hundreds of different categories. And there's one thing we only have once. So, yeah, so 2016, the CGI production started, and I came to Obi in 2019, so there was something. And there was something big already, growing fast. So there were these upcoming configurators, like we had over 10 of them, layer configurators. So a lot of digitized products and a lot of renderings being done. Yeah, some examples. There was a first production, and everything was done by an external production team, and our pipeline was based on 3ds Max and V-Ray. They worked with very sparse reference images. There have been photo shootings. There was a test doing photo shootings a long time ago. It was very you had to do with cleaning up the products before shooting. The products are bulky and heavy, and it was a huge logistics, and so it was very expensive, and we had to find a way. Yeah, and also we had an external development team with CGI expertise, so we could do a lot with it. Yeah, growing model library, varying quality were kind of our issues. Relatively low technical standards. I mean, it was focused on speed and on changing materials and colors fast for creating a lot of renderings and a lot of variants. So we knew there was an upcoming challenge, kind of a content push. We had to try to replace photography to be able to push a lot of content into the web to make Obi apparent. And we wanted to modernize all these configurators. Okay, so we kind of had a very rough goal, but one thing we knew, we had to do photorealistic imagery, so we had to produce photorealistic images ready for use, and for future applications, we didn't know exactly what that was. So keeping everything at low cost was a no-brainer. Yeah, so we thought, okay, can we build a model for any use case, nearly photorealistic offline renderings, 3D models in our online shop, and of course product images for web-based planning tool, and for AR for our customers, and so on. So yeah, the beaver had a lot to do. We started defining a strict base model standard. We checked the industry and the tools and everything we knew of for the most compatible feature set. And of course, that we also did some basics, introduced some basics like positioning for the different categories of the products had to be consistent. Orientation, we introduced the PBR metallic roughness workflow. We took care about mesh quality, like isolated vertices, degenerate triangles to avoid crashes with engines. And we also had FIONC naming things ongoing. So we required the production team to always output this base model, which we could then export to anything we like, basically, and use for anything we like, and of course use it for rendering. But we knew the base model couldn't cover every photorealistic detail, like subsurface scattering. You cannot really cover with every engine, and it's kind of complicated. So we opened the standard for an additional model, like the extended model the designer could provide in addition. And use that, I just use that for offline rendering if it's there. So low costs, ensure standards. How do we know that everything we get is the perfect base model we dreamed of? And how to keep the frustration level low, because if you put something in and you put that hard, strict standards to the production team, there is a lot of change going on, of course. So we planned to, and we also did, to introduce an asset guide and an asset submitter plugin. So the asset guide is basically the specification for our standards, and but it was aimed on to the designers that could understand the explanations, like what are degenerate triangles and how to avoid. And the asset submitter plugin we called was a 3ds Max plugin, so the designers could check their models directly while during modeling and shading. We provided automatic fix functions, and during the submit process we also could control the rendering, standard renderings of the product images and export formats. So the designer got direct feedback. Every error we provided was linked to the asset guide. But nevertheless, the introduction of these standards and tools, was a lot of work, and every team involved had hard times to adapt to our vision. So designers were restricted suddenly on the use of nodes and attributes, and had to get used to it. The PBR workflow was in the game industry, it was evolved, I think, but in the architectural industry it just came up, so they had partially to learn what this is. There is something with groups and hierarchy of 3ds Max users. I'm coming from Maya. Maybe somebody of you heard of it already, so that was an issue, but we managed it. And requiring clean geometry, I already mentioned. The developers also had to fight against something like, the implementation of the output color map in 3ds Max from the bitmap node. I hope someone was laughing at this point, but no. It's a bad implementation. They fixed it now, but we originally used the XView checks of 3ds Max to get speed and development, but we got very slow results, especially with the overlapping phases check. So project managers, of course, had to adapt to the processes, and yeah, we changed and we extended our standards, of course, and that always was a lot of work. And we had two worlds, the old products and the new products following the physically based rendering workflow. So you have kind of, you want to go on with your production because everything was running the whole time and we're putting out a lot, and so we had to take care about the post-production that suddenly changed a bit, and because you have other black and white values in your objects and your materials, and yeah, so we started rebuilding some scenes, and yeah, that was a challenge, but there was a lot of work to do, but I think we had a good environment and good teams to tackle this. So the main benefit of that what we achieved was to have that base model, and I would just show you how we currently receiving the 3D models from the production team. We have a clean 3ds Max file, no garbage in it. We have standardized renderings being automatically created during the submit process. So there's a technical review image for our review processes with some details like polygon count, V-Ray version, etc. Plus the JSON file was containing a lot of more metadata. We export an FBX file for another planning tool, and of course we have a GLTF binary, and that was quickly introduced in the review process for showing measurements directly, or yeah, looking at the backside and so on. And that, of course, is the base for optimization. And how did we create, or do we create this? Of course, we had to create the V-Ray materials, convert the V-Ray materials to something compatible. That was, sorry, I'm too fast with my finger. That was the physical material mainly since Max 2024. Of course, there is a GLTF material and some changing environments, but yeah, then we need to convert the normal map to the OpenGL standard. There are some requirements to set up, like to take care of cutout and opacity things and transparency things. Then we export the GLTF file in this JSON format to be able to modify it. So we are using Babylon.js exporter, then modifying the GLTF, for example. Yeah, some things the exporter does not do like we think it should do it, and so we modify the GLTF file. And then just putting out the GLB, and can do whatever we want, and are very excited to have a GLB file, for example, for putting it in the PowerPoint presentation. Evolving industry standards helped us a lot. Well, that's one thing, of course, all teams that were involved in it helped us the most, but the industry standards that came up were just the great source for choosing standards like GLTF and USDZ features. What do they support? Well, USDZ is always a little bit tighter than GLTF, and yeah, V-Ray developed further. Yeah, Kronos, of course, was a great source. Physical material improvements and 3ds Max. There were more tools like Substance and so on for the designers. So we did it. And yeah, we were able then to provide our new upcoming 3D planning tool with yeah, optimized 3D models. And now I'm coming to the use case. It's a garden planning 3D planning tool, web-based, and so we had some challenges, like a lot of relevant articles. We had to, yeah, we could pick out some of them, but we have still been hundreds of them, and the challenge of displaying hundreds of models, hundreds of instances in one project in the browser. Of course, there is a need for very low triangle counts. Consistency, precision, everything we needed. And the production team had sometimes just had one image and some measurements to produce it. So a very difficult production. And we had different kinds of assets because we have a calculation service implemented that lays out and cuts the product for the individual shape the client needs for his garden planning, for his terrace planning, and there were some objects that could be calculated and some that could not, like gravel pavement things, and so we had to take care about them in another way, like making laid out patches. And like kind of a texturing challenge was that we have very long, very thin objects, because if we are cutting down products, we have to take the longest variant we have. Sometimes it's 6 meters of length of a terrace plank in 14 centimeters wide, and then you have a continuous wood structure on it, and please optimize this texture in automatic way, ideally, and that was a kind of a thing we had to take care of. I'm a little bit late, so I'm going to rush over this one. So we did a classification of the 3D models. As I said, we have the solo models that could be laid out. And we thought, okay, we need 1,000 polygons or triangles and even less. So we took every object with less than 5,000 faces and decimated them to 20% using the rapid compact CLI. And the rest above 5K triangles we decimated to 1,000 faces. So these are some other specs we introduced. I think relatively, it's clear and more or less standard, I think. And the second approach was to take these laid out patches, model in high poly, exported in GLB, of course. We had to take care of cleaning the mesh a bit. We did it, some manual steps on Blender that, of course, could be automated. And then we also created a bounding box geometry with UVs on it, and then we baked the high poly GLB file onto the low poly bounding box object, and that was enough to have a representation. That was also enough for the client. Well, I'm a designer, so my heart was bleeding a bit, but it's not my part. So this is a good example for a wood structure of a terrace plank. This is the not so good example due to the length of the object. But in the end, for example, this object worked out quite well with the remeasure. So you really have the stones onto it. And this is the view of our planning tool. It's a top view now, as you wonder, what? It's not 3D. It is 3D, and there will be a point where we change the perspective, but it's easier for the UI development and currently to be faster, do it in 2D. A quick outlook. We will look at garden furnitures, because if the client has a terrace, he might want to see how his garden or her garden furnitures look on this planning. That will also be a challenge due to relatively complex models. And of course, we have a long backlog, improve texture resolution, reduce special cases we always have to take care of manually, texture variants, the whole integration of this process, and so on and so on. So Yeah, there is an end of the list, but it's not in this presentation. And that's it. Thanks.